frame or odometry frame to that group. So we have a pre-planned trajectory, which so because we knew the track in advance, more or less, like 10 centimeters or less. Yeah. So wow, that's so far so awesome. Look at this.
Let's go.
And does it yeah, we filled the point cloud, so it's
a very good first trial. Very nice. Very successful first trial. Very smooth. So far, the best first trial.
Yeah, that's awesome. Actually, we haven't planned. We didn't do any drive tests yet. So we did like 2 flights, so that's awesome that we actually did it.
So during your practice flights, how many gates were you able to clear?
We cleared 4, the best actually yesterday night, and then today we did 2. So actually we great.
Now, how long did you guys or you and your team prepare for this competition?
So one moment, maybe we'll start the next round soon. So yes, we were like very constrained by deadlines and stuff, so we didn't have too much time to set up everything. But we are relying on a big stack of software we're developing at our lab. So for example, for the motion estimation, we are using Rovio, which is a framework developed at our lab. So that's visual odometry framework. And then for the path planning, we've been using path planning before in our other projects. So we use polynomial path planning to go through these groups. And we used all of these software stacks now, put them together on this drone, which we also stack together to apply this race. Yes. So let's get back to the platform maybe. So we're using an S-Type Hummingbird quad loader. We put a outboard on it and use a free sensor.
Wait for the okay here.
Okay.
Yep. On my mark. 3, 2, 1, go. There it goes again, very smooth. Take off.
Now it gets the first detection and aligns its takeoff position basically to this first group.
What's causing the hiccup to do it?
Would be good to know.
I mean, so far it's been very smooth actually passing through the open gates. Those are coming up. That's it. Goes through it nicely. Very nice. Now this is where it actually had what's called last time. Okay, alright. Okay, now in all fairness, it's very smooth up to that point. Okay, so some adjustments can be made here. Now, regarding your visual-based sensing, can you tell us a little bit more about that?
Yeah, so it's the Rovio visual odometry framework. So we have we have a front-facing fisheye camera on this drone in the resense, and then it detects features in the environment, and then consecutive images estimates the velocity, the pulse of our drone. So what's the big challenge here in this drone race, I guess, is having a good positioning of the drone, because so we are also, like the other teams, using onboard sensing only, so you don't have any exterior sensors as well that give you any any pose estimation, and so this framework of course drifts, so we don't have like a fixed point in the work, so we drift off, and that's why we need the alignment. So there we use the colored depth image and then detect these hooks and align to the center of the hook actually.
No, I mean, would you say this course is probably one of the more difficult courses that you tried, or somewhere in the middle?
Yes, I mean, in previous projects we have been also like, for example, we were flying in factories, for example. So this was like a little bit bigger framework we were using there. So we were actually mapping the whole area with a bigger drone, actually with a hexacopter. And we had then we were mapping everything and let the drone autonomously fly around and do stuff. But this is also like very, very challenging, obviously. Yeah, right. Yeah.
So I have also a question, couple of questions. So a lot of the robotics society, a lot of people think or say that actually the SLAM problem is now solved for autonomous robot. What is your opinion about the drone in terms of the autonomous drone? You said you already mapped it and then it's just tracking, control, right? So if you do the SLAM, it's not the map is given, then how would the problem be more difficult?
So we are computationally very constrained on this platform. We are not using SLAM. We only use our Rovio system. Then we don't build a map of the whole environment. We just like keep this because it's computationally very lightweight to do this.
Okay, they're ready for the trial.
Here we go.
3, 2, 1, go.
There it goes. Now, how light or heavy is this particular drone that you guys made?
How heavy it is? It's 700 grams. It's like, I don't know, 30 centimeters, maybe diameter. So we didn't get plate protection, so that makes it a little bit narrower even. So but I maybe that will first to move the protection to the boots. Working for the hook.
Makes it pretty easy thus far. Turning around. Fourth open gate. Go to his first closed gate. That one's at 51. That's beautiful. Yes.
Can you talk more detail about your how do you do the fast tracking? Any special technique they use?
Yeah, so we are using model predictive control to do position controlling. So we use the onboard attitude controller to control roll, pitching yaw, and then we have a non-linear model predictive control to follow the trajectory. So this is pretty awesome because we can predict the future state of your map, and then it can predict these trajectories very closely. With little offset, we were applying in other experiments very dynamic trajectories actually. If we don't have to, I mean, if we like have better tracking or something, and we could go very quick with these controllers. It's great work done by Mina Kamre mostly. This is one of our PhD students who's there in the corner. So the other guys who are here right now are Michael Burry from our lab. He's also working on this and having a cover. So we are at the stage, but we are a bigger team. We have more people at home, probably watching right now maybe, and hoping that we make it in the sync group. It's of course it's difficult now to change anything in our algorithm. But I'm happy that this works.
So I saw your group actually posted a YouTube video on the internet that the robot builds up the 3D map using the high information, and then do the strength in those tools, right? So how much that technology is applied to this?
본색?
So, yeah, I think this is like, for example, the mapping.
드래기?
Mapping of the factory.
몰라.
There's video from it. So, we're not being this year at all. So we don't
안경 쓰고 그거
computational constraints, mostly, and
맨 오른쪽?
also,
맨 오른쪽?
No QR scanning.
Also, we don't do any QR scanning here, so I mean, it wasn't like the QR tag position was not given at the beginning, so you cannot actually locate against the QR tags unless you start measuring them. So we don't use them at all right now. We don't use that pipeline. We just rely on the routing basically as.
So maybe next term, if we continue this kind of competition next time, then maybe I can just get rid of the QR codes.
Yeah, I mean, maybe QR codes or AR tags would be nice as well. But I mean, it's not necessary. You can also do this like this. I think it's still it's a great competition because it's like challenging all the aspects of autonomous flying, like localization and everything. It was great for us, so we set up this nice platform. which is working very well.
일로 나오세요.
Yeah, and I think we go in the next run now.
We have a little bit over 17 minutes left, the clock.
Okay.
Ready to go?
Ready?
Ellen? Ready?
Ready.
3, 2, 1, go.
Goes. Another smooth start. I think it'd be wonderful to see your team actually clear all 10 gates.
I think we switched to quicker trajectory now. Let's get going now.
What do you think? What happened this time?
We didn't align properly against the second loop, so we drifted. So because we don't know the start position, basically, we just drop it there on the starting platform, and then we don't know the exact distance to the first loop, and so we don't know the exact yaw in the beginning. So this is very crucial in this challenge to get this alignment properly, and this is what happens basically, and this is the main issue.
We've seen other teams struggle on onset too as well, so I mean, I'm sure it's not a huge hurdle for you guys, but seeing the first two runs, how smooth it was for the first 5 to 6 gates.
So what is the secret of your team that you made a first 5 gate very smoothly?
Yeah, I think like overall the framework is great. I mean, it needs some properly testing and everything. So I mean, we have a great path planning framework, and it builds very smooth trajectories through the whole track. I don't know how the other teams did it, but we have like a pre-planned path basically, and the map just follows this. And the only thing that makes it shaky maybe are the alignments we're doing. So this gives like small jumps in the position estimate. Yeah, but I think this is like maybe the main ingredients that makes it look so smooth.
Do you do any dynamic readjustment, replanning?
Yeah, we do replanning, so if we diverge from the path, we try to get back to the path, we have a local plan that's really aligned on board. That aligns our path to the new frame.
Okay, so the detail about the replanning or
I'm not so firm on that right now, so
somebody else's work.
we are a team putting everything together.
Is there a specific vision for your team as far as what kind of applications you guys are working towards with drones?
Yeah, we have different projects running right now. So one is about industrial inspection and industrial, like also manipulation with drones. So actually getting into physical contact with, wind turbines, for example, to repair or do welding repairs and stuff. And then other projects are, I think we are almost at the next start.
We'll talk more about application in a bit. I think they're ready to go for the next trial. 13 and a half minutes to go, approximately.
Is she Helen? Yes. Yeah, Helen is checking the final steps.
So this time around, a longer flat tire.
We're ready. Okay, on my mark. 3, 2, 1, go.
And they're off. Just lift off. The trajectories appears. Nope. Always like that. Put a little hiccup down. There it goes. One quickly, yeah.
This time a little higher.
A little higher, yes. Now for the open gates, the height doesn't matter, right?
It shouldn't matter. Only the lower boundary. So, can you tell me about the hoppers on the robot?
Yes, so this, like I said, it's for part of the hummingbird helicopter, and our base on top of this platform we put this upward for processing. So great work. So this is our first. So we put this on the platform for the first time, and it's working great. And then also
So, there might be some people that are not familiar with what is the small ball, the silver.
This ball, that's a leftover from our lab. Tries basically so back at home we have a bike and tracking system that can give you exact pose estimations. So for validating our algorithms, we use this bike and motion tracking system. But we didn't really just take them off basically.
It's only for the verification.
It's for verification. So our lab group tries to do everything on board of the maps in general. So on the bigger drones we have bigger computers. And then but to try the algorithms is always comes in very handy to have some motion tracking.
All right, I think 2 sets.
The team is now discussing about
Rebooting the hardware now takes a moment.
ready.
We do this. Then we have another project about agriculture drones. So where you do agriculture drones. So where you do mapping of a field or try to detect crops that need to be fertilized or whatever. So this is another project. Then we have a project where we are also into industrial inspection. There in this project we were actually hosting the challenge ourselves, so we know about industrial inspections, so we were like giving tasks on what a drone has to do industrial inspection, like flying through small gaps or facing wind disturbances, so the controllers had to neglect wind gusts, so all this kind of stuff. So it's a very broad field, basically, of things we're doing. And also in the IROS project, we're working with manipulating the drones actually, and then try to manipulate things, getting into physical contact. And we are participating in the Ambition challenge. We also have to do evaluating for things.
So you have quite a bit of different designs, drone designs, because you're working on simultaneously at the moment, yes?
Yeah, so we're not building the drones ourselves, so mostly we use like other companies' drones like Aztec or then I drove some of this and was like setting up the hardware also.
So how is this so far here? Just working on. So Helen.
Yep.
Ready? He's pulling.
Okay.
All right. Ready. Okay, 8.5 minutes to go.
3. Are you ready?
Yep.
3, 2, 1, go.
Another look up again. Hoping it'll test forward here as it is.
If this line is high enough, okay, again high.
Okay.
If it's high, it's down there.
That's right.
I'm very happy. I'm very happy with the first runs. They were awesome already, and let's see what more we do.
I mean, technically, you have 7.5 minutes. Probably enough for maybe 1 or at least 2 more trials potentially, depending on how fast the turnaround time is for resetting the system.
I believe the price also made the best one, best trial.
Oh, so okay. So Kai's time is what actually. Okay.
We still have they made the best record for the last time.
That's true. So perhaps maybe his team is also saving the best for last as well.
Yeah. Little adjustment can improve.
Can make a big difference. That's right. Well, I guess we're all hopeful for you guys. Going for you guys as well. Yeah.
So basically, what do you guys do whenever it stops and reset? Do you change the track path?
So right now we cannot do much more, and we're gonna try to fix maybe some waypoints and see where we can get. I can guess because this big system there can do many things wrong. But we'll start next one.
Okay, we're ready. All right, go. Sit a little less than 6.5 minutes.
3, 2, 1, go.
And it's off. We're expecting a heat up here. Right about here. Yeah, there it is. And then our tails. Slowly but steadily approaching the first gate. Yep. This time it's not going high. It's actually maintaining its altitude to the second gate. Alright, so far so good. Approaching the third gate in the left corner. Mix around successfully. Alright. Fourth gate, cleared.
Super exciting!
Yeah, looking good. So far so good. Yeah, as I said earlier, I mentioned earlier that the pillars were not protected. So, do you guys have a picture like the guys team to put together? What was the prognosis?
So we have a broken sensor mount, I guess, and a broken up computer mount. I think basically a lot is broken out. But good thing we made it so far. It's an awesome challenge, really. It's a great thing.
So you guys cannot do such a thing like high speed of. Oh, okay. Yeah, the weight has to go back and then get some information.
Give some updates to see. I guess we'll find the severity pretty soon. And I still have one more run. We still have almost a little over 4 minutes left, but
Now it's time for us to fill up the silence.
once again, any takers? Well, so far it's been pretty something. Okay, yes, okay, and the prognosis is good.
Yeah, I think the road is really good. It has to go have a rest now, I guess. The sensor mount is broken, and also all my damping is broken. A lot is broken. Then the failure, why it crashed into there. But I think already so far we are very happy with what happened, and we also happy to answer questions later, like more detailed questions and how we're doing things and stuff. Yeah, that's been a good time. Also, like the other teams, everybody did great. I think it's a hard challenge also, so I guess that's why many teams dropped out actually. But I think, yeah, drone race can be done soon.
Well, everyone, let's give it up for a team from Switzerland.
Thank you guys.
Thank you guys for coming. Impressive round.
Okay, I think it's time to wrap up. Although we have the team has 3 minutes left, but they finished because of the damage. So the competition is now over. I'm gonna go check the time and the scores, and then we'll come back.
Define your own